Hello, everybody. My name is Philip Wightman. I am a senior network architect here for Laketec Communications out of North Olmsted, Ohio. And I thought I would do a recording on some common wireless troubleshooting commands that I typically use in the environment, any customer's environment. I actually did this with a customer the other day, and I thought it would be beneficial for everybody to see. This is primarily focused on AOS8 controllers being managed by Mobility Conductor, but a lot of these commands also transfer over to AOS10 gateways as well. So let's go ahead and get started. So first up, just going to show you a couple things in the UI here. We're going to do most of our troubleshooting in the CLI, but from the UI perspective, oftentimes we want to see what the RF in the environment looks like. And right here from the landing page, the dashboard overview, we have a radios section in the bottom right-hand corner. Now, of course, this is a lab, so there's not a lot going on, but this radios group by, I think channel quality is the default, changes the channel busy. And you're showing, what type of, how busy your APs are. If you start seeing APs in the 60 to 80% or 80 to 100%, there is opportunity there to either deploy more access points or maybe you have code channel in the environment. So we can click right into these to take a look at the radios for whatever specific section you're looking at. It's going to take us over to this other screen that's showing the channel busy. And I might have added that in there. This might be a column that you have to customize here. But if we add the channel busy, we're able to sort by utilization. And on my screen here, it's obviously very straightforward because I only have 2 APs. But if you had hundreds of APs or thousands of APs, you're definitely going to want to be able to sort this. And one of the things that we're typically looking for here is when we have high channel utilization, like I'm at 16% utilization with no clients on this AP. That's a clear indicator of code channel. So this is 6 gigahertz, it's kind of to be expected. So this isn't really that high for code channel. But in your environment, this may be up in like 80, 90%, and the resources in the AP are being wasted by code channel. So something to look at for tuning, you might want to turn 2.4 off on some surrounding APs, or just visit 2.4 in general across your environment, or disable it. The other thing I wanted to show you here is that we can also go into the radios directly. So instead of going into a specific channel busy, which I would just click on that, but if you wanted to go directly into say 2.4 and look at all the radios, and again, there's only 2 APs in my environment, that's another way to do it. Okay, I'm actually not going to do anything else in the UI. I just wanted to show you that and focus on the CLI for the remainder of what we're going to show today. So I am logged in to the Mobility Conductor, and the Mobility Conductor is what we use to manage, monitor, configure our mobility controllers. And just a few quick commands just to get our bearings and how we know or what it is managing is we have this command called show switches. Show switches is showing what controllers are in the environment. And in my case, I have a primary mobility conductor and I have a standby mobility conductor. So a layer 2 standby mobility conductor. You could also have a layer 3 standby mobility conductor, but that's neither here nor there for this presentation. The 2 things we want to focus on here is that we have 2 controllers we're managing. So again, very small environment, very small controllers, but everything I'm going to show you is the same. Matter if you've got lots of different clusters. So from the Mobility Conductor here, I can actually get into any of these controllers. I could start typing the name of one of them here. I'm going to go to the 7008, and now I'm in the context of that controller. So this is where I make config changes on the CLI if I wanted to, but more importantly, I'm going to do what's called a Manage Device Connect, and that's going to take me over and put me on the CLI of that controller. So I don't have to worry about keeping secure CRT or PuTTY sessions for each one of my controllers, although I do have that built out. Sometimes it's easier to jump into one. But oftentimes when I'm in a customer's environment, it's just easier to get the list of controllers and discuss which ones we're going to look at and then navigate into them in that fashion. Okay, so a couple tips here. The grepping or include command is your friend. So if we're going to look at say the user table, we see we have you're going to have hundreds if not thousands of users connected here. Your include command is very, very beneficial. So I can include say let's do something unique. Everything's on 5 gigahertz. Everything's on the same SSID. So not a lot of unique this year, but I can do say I want to look at everything that's on the 1010 network, which is it is the same output because everything's on the 10 network. But we can also double grep these things as well, or double include. So we can do things like this. And obviously, I don't have a lot of unique. Oh, here's what I would want to do. I'd want to include maybe the MAC address of the client that I'm targeting here. And we're going to get into this more specifically. That's pretty cool because you may be grepping on groups, you may be grepping on AP names potentially if you're doing a show AP database, which I'm going to show you here in a second. And while we look at this config, I'm actually going to connect to the controller. I was going to do this earlier. I apologize, I'm not already connected. I think that's the password. So that way we can play with my client as we show examples. So if you show user table, I think I have the password wrong. Okay, well, I'll continue to go and I'll mess with connecting my iPhone here in a minute. So that's really cool, to be able to use the grepping commands. So just remember that, as you move forward. I think I just connected here. Yeah, so I am connected. We will play with my client a little bit later. So I am the 047E. Another handy command, again, not necessarily super related to the wireless troubleshooting. I mean, it is in a way, is the show AP database command. So oftentimes I put long in here because long gives you the ability to view the MAC address of the AP as well as the serial number. And this is handy, if I'm looking at, troubleshooting a specific AP, I'm trying to find it in the environment. Maybe I'm looking at LDP neighbors in the environment. So show AP database is a common go-to command. All right, so really getting into it, you can see we've got only 2 APs up in the environment. Again, it's a lab, so not a whole lot going on. One of my go-to commands is looking at the power of the APs because it's really important that power is balanced well in the environment. So the command I just entered there was show APBSS table. So this is showing the basic service set for all the radios and all the APs in the environment. Again, you might want to grep this, but just looking at it holistically, what we're targeting here is the information in this column. So what this is showing is what channel the AP is on, what ERP it's currently running at, what its max ERP is. So when I'm looking at the customer environment, I never ever want to see anything over 21 here. Anything over 21, the power is just too high, and that leads to all sorts of asymmetric client connectivity issues. APs or clients are hanging on to an AP because it hears it loud and clear, but the AP can't really hear the client because the client can't transmit above 21 dB. That's one of my first go-tos, so I use that command all the time. If they are high, you'd want to go adjust your channel plan or your RF power plan. So another handy one I use here is show AP ESSID. So this is the extended service set ID. So these are all of the SSIDs that are active in the environment. So yeah, I've got some funny ones here. Again, this is a lab. So this is handy because not only can we see all of the SSIDs that are, I shouldn't say active, that are configured in the environment, but it's also showing what is the default VLANs for those APs. Like this one here, it looks like I probably have it configured in 2 different AP groups, and the default VLAN between those AP groups is a little bit different. So at least I know what the default is, because this can help in troubleshooting later. Because oftentimes, especially for an 802.1x network, your radius server, say it's ClearPass, may be dynamically sending down a VLAN when the client authenticates, which maybe is, let's say it's VLAN 20 for this particular SSID. But at least I know what the VLANs are, and I also know what mode it's operating in, what encryption methods it's got enabled, and really, what's the spread of the client. So it looks like everything in this environment is connected to this particular SSID here. Okay, so that's a nice handy command. And then I showed it earlier, but I didn't really tell you what I was doing there. So actually, we did talk about show AP BSS table. So yeah, we covered that already. But that's showing we can also see the name of the AP that has the different SSIDs enabled on them. It also shows who's connected to what. So we got 3 clients connected to that one AP right there. But this is all one AP. So maybe I'd want to narrow that down. And I know we want to look at the DEN AP, and then specifically I want to look at the Find Me SSID. So there's the 2 SSIDs, and then maybe I want to look specifically at 5 gigahertz. There we go. Okay, so a lot of time, so that's kind of going over super basic RF, but some really quick hitters to go and look at. So now I'm going to change focus and look at the user connections on the controller. So we have 2 different major commands to look at. The first one is the show station table. So there's two commands we're gonna dive into. One shows station table, the other one show user table. Show station table is the layer 2 view of your clients on the network. So here again, we've got 4 clients that I just connected a little bit earlier, and this is my layer 2 information. There's no IP here. The reason why this is important because if you're troubleshooting a DHCP issue, or just a layer 3 forwarding issue, you won't have a layer 3 entry in the user table because the client doesn't have an IP. So if you're troubleshooting DHCP issues, you might not see anything. I almost always go to the show user table first when I'm doing my troubleshooting, and if I can't find my if I can't, didn't mean to, I accidentally pasted a whole bunch of stuff there. Let's refresh that command. Okay, let's just type it again. So again, show station table. My finger's not working today. Show station table and show user table. I usually start with the show user table, and if I can't find my client in the user table, then I will refocus on the station table here. So looking specifically at the user table, this is how I'm going to grep this to figure out what I need. Maybe I got part of an IP address from the end user, or maybe I got part of the MAC address. Either way, I'm gonna grep for that information. I don't need to do it again, but I'm gonna grep for it so I can get the MAC address. And I like to get the MAC address because my go-to command for most of my troubleshooting is doing this command here, show user MAC. And then I will take the MAC address of the client and I'll plug it in here. I like this command because we get a lot of very good output here. We get a lot of detail for this particular connection. Some of this detail, it takes 2 or 3 different commands to get all this info. So by doing the show user MAC, it combines a lot of it together on the screen, and a lot of it I'm going to be using anyway. So some key points here on the show user MAC command. We get to see the IP, we can see the MAC address, how long it's been connected. I just connected my device a couple minutes ago. We see that the VLAN derivation, meaning that did something else trump the default VLAN and did not. So nothing sent down a different VLAN to the controller to dynamically position the client on. So I'm using the default VLAN there. I can take a look at, what AP I'm connected to, what the BSSID is, what the AP is, what the AP's IP, if I need to look at any of that. Lots of other useful information here for different miscellaneous troubleshooting. I did get an IP via DHCP. Again, you got consolidated information here for the BSSID, my client's MAC address, the SSID I connected to, the VLAN it positioned me on. And this is kind of cool right here. So the PHY, so this is showing what the AP is capable of. So these are some older APs. I think these are 802.11ac Wave 2 AP. So they're capable of very high throughput, 80 megahertz single guard interval and 2 spatial streams. We have what the client is capable of in the further output here. So this is a newer client. So we can see here it's doing AX, 802.11ax for high efficiency, capable of 160 megahertz wide channel, 2 spatial streams. We see the different types of maybe protocols that were utilized during the association, which is handy if we're troubleshooting maybe some roaming issues or some quality of service issues. So we see that we're capable of WMM. We are using 802.11v to help with roaming. A just means it's active, and B means that the controller, if it sees that this client is on a channel that maybe has high co-channel or high utilization or lots of errors, it could try to steer that client over to a different radio, either on the same AP or a different AP, so that it can get a better experience. That's what advanced steerable is. And then down here, we're seeing information about the AP itself, the channel that we're connected to. We see we're on channel 44, and we don't have a lot of information here. So with a controller environment, with a clustered environment, the APs can be, you're usually always load balances the controllers to keep the control plane balanced between all the controllers in your cluster. And then the clients are separately load balanced to the controllers to make sure we've got a good spread of the client and device connectivity across the cluster as well. So that's the whole point of having a cluster, is that we're spread out. And then if we have a controller failure, we have hitless failover, which brings a user over seamlessly. Because we have an active state, and we'll get into that more in a little bit. So I just connected, so we don't have a ton of stats here. I got some transmit receive. My SNR isn't horrible, but it's not super great either. 28's okay, I guess. You know, anything above 25 is usually pretty good. But these are some stats that we'd be looking at when we're doing some client troubleshooting. Maybe we'll see that the frame rate is really high in the AP, or the retry rate's really high. Same thing for the user. Maybe we see that this is, you know, in the 30s, 40s, 50%, which is not good. Same thing with the AP. Okay, so that's a very handy command to know. Again, lots of information I didn't get into, but it's more introducing you to the command so that you can you know, start playing with them yourself. Another command I use a lot is the show data path. And first, I do the show data path session. That's usually my go-to. But if we question mark things here, we see we got a lot of data path we can look at. So I think I mentioned it a minute ago, but the controllers have a fully stateful firewall built in. So they're seeing everything layer 2 through layer 7. And we're going to look at an example of that here in a second. But the show data path command is a very powerful tool because I can see everything that's going on with the flow of traffic. So I like to target the show data path session, which if I just hit enter here, we're looking at all the layer 3 sessions that are going through the controller. Again, not a ton there because there's only 3 or 4 clients connected. But what I want to actually do is grep that with the IP address of my client. So if we do show data path session, we can include, maybe we've include the IP here. And now I'm looking at just the sessions for my iPhone I just associated or authenticated to the controller a few minutes ago. So this is huge. So as we're, you know, troubleshooting maybe application connectivity issues, which is a common thing that we get, we can take a look at this output here. And actually, let me do it raw again so we can see what the headers are. So here we see our, you know, what our flags are and then our headers. So if we look up at what I was doing here, one of the things I'm looking at is the flags over on the end. And there's 2 very important flags I look at. One is the deny flag. The deny flag, if I had a capital D over here, that means that the controllers themselves are denying traffic. They're dropping traffic based on an ACL. So we're going to get into the ACLs and the user roles in a minute. But that's what the D's for. That's a clear indicator that, you know, whatever is going on with the application connectivity for that client, the controller is dropping it. Maybe it's for intended purposes. Maybe it's not. Maybe it's a misconfigured ACL. The other flag I look for is the Y flag. So Y is no sin. This is again a stateful firewall. So it knows that when we do a TCP handshake, if my client reaches out, and in this case, it looks like maybe we caught it in the middle, but it's so if I start a TCP handshake and whatever I'm talking to doesn't send back, that means that whatever we're reaching out to either just doesn't exist, it's a bogus IP, or it can't be reached. Maybe there's a firewall in front of that thing, or we've got some routing issues. No matter what the case is, the Y means the controller's sending it out, but it's not hearing anything back. So that's a clear indicator we have a problem upstream. It could be, you know, the fact that we're missing a VLAN and an uplink. It could be, you know, the path through the network just need to be investigated. So this is almost always takes me right to the infrastructure and just takes me off the controller because I know that we've got a problem upstream. Here, we're breaking things intentionally via ACLs, and other places we're, you know, having a problem upstream. So D and Y flags are the 2 common ones I look at. Sometimes we're troubleshooting QoS, and we may be looking at, you know, this deep packet inspection, you know, actually grabbing the traffic. Do we have, you know, the quality of service that we need to see? A whole bunch of, you know, really good things here that we can see for flags. Okay, another go-to on the show data path would be excuse me, I didn't hit that is the bridge table. So this is layer 2. So we're seeing all the MAC addresses on all the VLANs that are configured on the uplink of the controller. And sometimes I might actually take a look at the client session just to make sure I see layer 2 there, and I know we will. We know we're on VLAN 123 here, and my MAC address was this guy. So again, I could do the same thing. I could include my MAC address. Show data path bridge to include my MAC address. And there we are. So we could see that my MAC address is on VLAN 123. We knew that. But sometimes, you know, we might be troubleshooting a client that's on a network that's not heavily used. But this would be an indicator that I'm hearing other things from the infrastructure because, you know, it's a layer 2 VLAN. So any MAC addresses that are on the infrastructure side are going to be heard by the controller, and the controller is reporting that here because it's showing the MAC address table there for that VLAN for what it's heard. So handy command there. Another handy command. So if we go back to that example I was talking about with the show datapath session, let's say we had a D flag here. The D flag would indicate, again, the controller's dropping traffic. Anybody that's familiar with the Aruba world knows that any and every client gets put into a role. So we go back to the user table here. So every client gets a role, whether it's a default role that just happens to be created when you create the SSID, or you're intentionally creating roles to put intentional policy and ACLs on a client, which is usually the case. Most customers will create roles to be able to control the client's traffic, especially for like a guest user. You're going to block everything that's going to production network, but allow anything out to the internet. So we have a role here, so we can start looking into this. So I can take a look at all the roles on the controller that have been defined. So show rights is the command there. Sorry, I shouldn't run through that super quick. So we got the show rights command. So as I show rights, I can look at all the roles that have ever been defined on the controller. You can see there's a lot of messy stuff here because I do a lot of lab testing. But we can take a look specifically at what that looks like within like I talked about, a guest account. So if we take a look at this guest account, we can see if the user role itself is configured to put the client on a VLAN. And I think because it's not showing here, I think there's another line somewhere up top here. If we were staticking a VLAN, not staticking, we're configuring the role with a VLAN, we would see that there, because that's one way we can steer users to a different VLAN is via the role. We can see the policies here that are assigned to that role. These first two ones are default policies that the controller puts on all user roles. But then here's our custom ones. Here's all the custom policies that we define, and we can take a look at what those policies are. So treating guests really has nothing in it. It's just an empty policy. We have the logon control. So this is what, and this works like an ACL top down. So it looks like we are denying UDP 68, which is, I believe, being a DHCP server. So the client can't be a DHCP server, but it's allowing ICMP, DNS, the common things that a client's always going to need, especially even if your DNS, DHCP servers are production, especially DNS. You're not steering them towards internet-based DNS servers. You, for maybe purposeful reasons, need your internal DNS to resolve IP. So we want DNS. And these are, obviously, you create these and adjust these. So if you didn't want that, you wouldn't put that there. So here we're saying that the destination training RFC 1918. So this is an alias, which isn't showing the alias here, but it basically has all of the RFC 1918s. Your 10 dot network, your 192.168 network, your 172.16 network, and it's denying it. So we're allowing you to get IP. We're allowing DNS. We're allowing DHCP. We're denying all other traffic to the production network, and then we're permitting everything else. And what is everything else? The internet. That would be an example of how we can look through the policies that are applied to a role to figure out why things are being denied. Maybe we saw D flags on a production network. Maybe it's going to 10, 10, 10, 100. So that would definitely be caught by this particular policy here when it gets denied. So that would make perfect sense for that particular deny flag issue. And I'm going to pause here because, as you see, I've got a meeting I got to jump on to. But we can consider this a wrap on part one. We're going to go into part two in the next video.